Welcome back, ladies and gentlemen. Mr. Brescher here. Today we're going to take a look at decimals or problems involving the multiplication of decimals. And by the end of this lesson, you will be able to estimate or use estimation to make sure that your answer is reasonable in a decimal problem. You will also be able to find the product when multiplying two decimal values. Now this covers a variety of standards, but mainly we're going to focus on the academic standards listed below. So take out a pencil and a piece of paper or a dry erase marker and a dry erase board so you can follow along. First we're going to take a look at some modeling. Many of you know that 4 times 3 is equal to 12. But what happens when we actually model 4/10? You can see the shaded part makes up 1, 2, 3, 4 out of a total of 10 parts. So if I were to model 4/10 times 3, what will my answer be? Let's just go ahead and do that. Here's 1, 2, and with the model I have already, that's 3 times 4/10. Now if we make these into individual parts, I can actually move them over so we can see that now I have 6/10 here, 7/10, 8/10, and I'll do the same to this one so we can see again I have 9/10, 10/10, which is a whole, and there are 2 more remaining. So I have 1 and 2/10. So 4/10 times 3 is actually equal to 1 and 2/10. Notice the similarities. 4 times 3 equals 12, and here we have 4/10 times 3 equals 1 and 2/10. See if you can make the connection when we look at this next example. Here we have a model of 4/10 again. And over here in blue we have a model of 7/10. Now we know that 4 times 7 is equal to 28. But what happens when we have 4/10 times 7/10? If you could imagine this as a rectangle, and we have an area over here of 7/10, and on this figure we have an area of 4/10. When we combine them, we can see that it divides this new figure up into hundredths, in which each square is 1/100th. And if I go through and count them, I have 7 going across, and then again I have over here 4 rows. So 4 times 7 is 28. However, this is representing 28 hundredths, so my decimal would actually be right here. That's what's actually taking place when we multiply decimals. Now let's move on to some more examples. When we look at this example right here, we have 14 and 8/10 times 3. Now, if I move it and put them to where they are vertical, we can see that I do not have to line up my decimal. This is not like addition and subtraction where the decimals line up. In multiplication, you simply multiply just as if they were whole numbers. So we're going to kind of imagine that the decimal is not even in place on this particular page. Now it reads 148 times 3. 3 times 8 is 24, and I carry my 2. 3 times 4 is 12, plus 2 is 14. Carry my 1. 3 times 1 is 3, plus 1 is 4. Look at that, 3 fours. Now, when I need to determine where my decimal goes, I'm going to go back to the white screen. I can see in this number there is one place behind the decimal. And in this number down here, there are 0 places behind the decimal. This tells me that in my answer, I should have a total of 1 plus 0 places, which is 1. So I'm going to take a decimal right here, and I'm going to move it 1 place to the left, 1 place over. My answer is 44 and 4/10. Now, you could also use estimation to help you out. 14 and 8/10 is about 15. And 15 times 3 is actually equal to 45. Is 45 pretty close to 44 and 4/10? Yes, it is. So I know my answer is reasonable. That doesn't tell me I have the exact correct answer, but it does give me a good idea that I have a reasonable answer. Now, what would happen if I had another decimal place? Maybe a decimal right here. Can you figure it out? That's right. You would just put one more over to the side. And now we have a total of 2 decimal places in my 2 factors, which means my decimal in my answer would have to move over 2 places. 1, 2. And what if we moved a decimal over here and added another 0? It keeps going. There's a pattern in which the number of place values behind the decimal in your 2 factors, these 2 numbers, you add them up, and that will tell you how many place values will be behind the decimal in your answer. So we can start here again and go 1, 2, 3 places. And then you can just add a 0 in front of the number without changing the value. Let's look at this problem. Here is an example of a story problem that maybe you can relate to in real life. Ashley wanted to put new carpet in her bedroom. If the carpet costs $1.27 per square foot, how much will it cost to carpet Ashley's entire bedroom? First, we have to know how to find the total area of Ashley's bedroom. Area is equal to length times width. The length is 9 feet, and the width is 6 2/10 feet. When I'm multiplying, that's what these parentheses suggest, to multiply. When I'm multiplying these numbers to find the area, I would write them up and down. But right now, it looks a little confusing or odd. Remember, when you multiply decimals, you're going to multiply them just like their whole numbers. And we know that the commutative property allows us to actually multiply them in any order or switch the places. So I'm going to commute my 9 down here, and I'm going to commute the 6.2 up here. Think of them again as if they were whole numbers. So I'm going to black out that decimal point. When I multiply my numbers now, I multiply just as if they were whole numbers. 9 times 6 is 54, plus 1 is 55. Now don't forget where that decimal was. There's 1 placed behind the decimal here, and 0 here. So I simply take my decimal and move it 1 place to the left to get 55 and 8/10 as my area. So that is how many square feet I have. Now I have to remember that it's $1 $1.27 per square foot. So I have another set of decimals to multiply. Let's extend this page. $1.27 times 55 and 8/10. Remember, multiply just as if they're whole numbers. Again, I'll black out the decimals and multiply as if they're whole numbers. 8 times 7 is 56. Whoops, let's use yellow. Carry my 5. 8 times 2 is 16. Plus 5 is 21. 8 times 1 is 8. Plus 2 is 10. And then I go on to my next number. 5 times 7 is 35. Carry my 3. If you want, you can erase the numbers that you had carried in the previous round. 5 times 2 is 10, plus 3 is 13. 5 times 1 is 5, plus 1 is 6. And now, since I'm in the hundreds place, I'm going to drop down 2 zeros, or write the numbers directly below the 5. 5 times 7 again is 35, so I will carry that 3 once again. 5 times 2 is 10, plus 3 is 13. Carry the 1 again. And 5 times 1 is 5, plus 1 is 6. Now, many of you probably noticed that we had a 5 in both of these, so it's the same number, just with an added 0, or multiplied by 10. Now when I add these together, I get my final answer of what looks like 70,866, but I have to remember where my decimals were. Here were 2 decimal places, and here was 1, so I have a total of 3. I'm going to have to move my decimal over 1, 2, 3 spaces to the left, so my decimal point will be right here. The answer is $70.86 or 87 cents if we round to the nearest penny. Let's look at some other problems. Use your pencil and paper to see if you can solve these problems now on your own. Then compare with the neighbor. Discuss the methods that you used to solve them and how you knew where to put the decimal point. Well, I hope this helped you out. See ya!